Imagine a computer unlike any we have today. It doesn't use bits, the zeros and ones that power our laptops and phones. Instead, it uses qubits, which can be both 0 and 1 at the same time. This is the strange world of quantum computing. It harnesses the bizarre rules of quantum mechanics to solve problems in ways classical computers can only dream of. For years, quantum computing was a distant promise, something out of science fiction. But now, it's rapidly becoming a reality. Companies and researchers are racing to build bigger and more powerful quantum computers. This progress has sparked both excitement and concern, especially when it comes to the security of our digital world. Why the concern? Because quantum computing has the potential to break the encryption methods that protect our online information, including the technology behind cryptocurrencies like Bitcoin. Bitcoin, the first and most famous cryptocurrency, relies on a revolutionary technology called blockchain. Imagine a digital ledger, distributed across countless computers worldwide. Every transaction is recorded on this ledger, secured by complex mathematical problems. These problems are incredibly difficult to solve, requiring immense computing power and time. This makes the blockchain virtually tamper-proof. It's like a digital fortress, protecting the integrity of Bitcoin transactions. This security is paramount because Bitcoin operates without a central authority. There's no bank or government controlling it. Its trustworthiness stems from the strength of its cryptography. Encryption is the process of scrambling information, making it unreadable without the proper key. It's the backbone of online security, protecting everything from our emails to our bank accounts. In the world of Bitcoin, encryption plays a critical role. It ensures that only the rightful owner of a Bitcoin wallet can access and spend their funds. It also safeguards the integrity of the blockchain itself, preventing fraudulent transactions from being added. Without strong encryption, Bitcoin would be vulnerable to attack. Hackers could potentially steal funds, alter transaction histories, or even bring down the entire network. To understand the threat quantum computing poses, we need to grasp how it differs from classical computing. Classical computers use bits, which can be either a 0 or a 1. Quantum computers use qubits, which can be 0, 1, or both simultaneously. This is called superposition. This unique property allows quantum computers to perform calculations in ways classical computers cannot. They can explore multiple possibilities at once, giving them a significant speed advantage for certain types of problems. One such problem is factoring large numbers, which forms the basis of many encryption algorithms used today, including those protecting Bitcoin.